Welcome back to Algebra 2 and Pre-Calculus. In today's video, we're going to review exponents. We started off with sets and then moved on to real numbers and their properties. Today, we're going to be talking about exponents. First off, what is an exponent? An exponent is basically repeated multiplication. For example, I can say 2 to the power of 3, this is the exponent part of it, is equal to 2 times 2 times 2. You're basically multiplying 2 3 times. So instead of doing 2 times 3, that would be 2 plus 2 plus 2. You're adding 2 3 times. You're repeatedly multiplying 2 3 times. That's what an exponent is. You say 2 to the power of 3 or 2 with an exponent of 3. This is called the base of the exponent, and this is called the power of the exponent. Now, you can generalize it with variables. A to the power of n is equal to a times dot 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 times a, and this is n times. So you're multiplying a n times. Now you might notice that I did a time sign, like a x sort of symbol for the 2's and a dot for the a's. That's mainly because I'm trying to transition us from Algebra 1 to Algebra 2. In Algebra 1, we did a time symbol because that's what multiplication was. Now we're going to be talking about variables and all that. We're going in depth into variables. So I would prefer to use a dot symbol. It's just easier and cleaner. You won't confuse that for an X. That's why I'm trying to transition us. It's a transition from Algebra 1 to Algebra 2. Now, what can we do with exponents? There are a bunch of properties of exponents. And again, I'm going to use variables like a and n. The first property is the multiplication of two exponents. So you have a to the n times a to the m. What would this equal? Well, the result would just be a to the power of n plus m. Both of those should be in the power. So it's basically you add their exponents when you multiply the powers. So if I add something like 2 to the power of 3 times 2 to the power of 6, the result would be 2 to the power of 9. And I'm just going to show you an example for the first one because after that it's all going to be similar examples. It'll be like 2 to the power of 6 divided by 2 to the power of 3. That's a bit of a spoiler of the next property, but still. I'm trying to transition us from Algebra 1 to Algebra 2, so it's like from numbers to variables. You should now learn to understand variables just like you would with numbers. Okay. With that out of the way, second property. Like I said, we're going to be talking about division. A to the power of n divided by a to the power of m. You can also write as a fraction a to the power of n divided by a to the power of m, like a fraction with a fraction bar, but it's virtually the same thing. What would this be? Well, if multiplication was addition, then division should be, yes, subtraction. It'll be a to the power of n minus m in the exponent. On to the third property. So we did two powers multiplied together, two powers divided, and now we're going to do a power of a power. So it'll be a to the power of n to the power of m. What would this be? Well, it would just be a to the power of n times m in the exponent, or in the power, right? So we had addition in the power, subtraction in the power, and multiplication in the power. Moving on. The fourth property of exponents is including two bases. So before we talked about two powers or two exponents, now we're going to be talking about two bases. A times b. So in algebra, when you're using variables, you don't really have to use the times symbol, especially when they're just to the power of ones, which is why I'm just doing ab instead of a times b. Again, transition. So you just do ab to the power of n is equal to, what would this be equal to? Well, you can just distribute the power and you'll get a to the power of n times b to the power of n. As you may guess, we would be doing a divided by b to the power of n. And as you may guess, it would be a to the power of n divided by b to the power of n. Property 6. the rest of the properties are just going to be simple properties. Anything to the power of 0 is 1, except 0. So 0 to the power of 0 is the only exception. Technically, you can prove it's still 1 using limits, but that's beyond our pay grade. A to the power of 0 is 1 for everything except a is equal to 0 in our standards. Number 7, a to the power of 1, anything to the power of 1 is just itself. So, like I said, raising to the power of 1, in this case in property 4, when you're just raising to the power of 1, you can ignore the exponent. That's basically what we're doing here. The final property is when you're multiplying something negative times. So that doesn't really make sense conceptually, but it's basically a power is negative. So you have 2 to the power of negative 3. It would just be equal to 1 over, now I'm actually using the fraction bar because it makes more sense with the fraction bar, 1 over a to the power of n. So you're basically taking the reciprocal of it. If I had something like 2 to the power of negative 3, it'll be 1 over 2 to the power of 3. And these are the 8 main properties of exponents. There's a few more that have to do with fractional exponents, but we'll get into that in a future video when we're talking about radicals and all that. For now, we're just going to be talking about a brief review of exponents. So here it is, the 8 main properties of exponents along with the definition of exponents. So I'll see you in the next video where we're going to be talking about other algebra 1 topics such as order of operations, order on the number line, absolute value. That's going to take up the next few videos. Then we'll launch into polynomials, factoring, rational expression, and radicals. So I'll see you in our next video.